If you like my content, please like, share and subscribe.
Hello everyone. So today I'm back with another video of NumPy. So in my last video I have talked about NumPy basics, which is absolute necessity for any beginners in the Python community. So today I'll be talking about the extensive advanced techniques of NumPy. But before that, like just to recap, so we have discussed these many things in my last video, so which is how to create basic arrays. So I've also shared this Jupyter notebook in my description of the last video. Please go check out. Very important library in order to learn data science, machine learning or deep learning, and NumPy is a absolute necessity. Adding, sorting or removing, okay, how to know dimension, shape and size of a NumPy array, so very important. And then we saw that how to convert an 2D array, 1D array to 2D array or 2D array to 1D array, and we'll be seeing some other examples as well today about how you can flatten a 2D array into 1D array. So here we have this reshape new axis keyword and then expand dimensions. So these are the methods that you can use to reshape. Then we did slicing and indexing. Again, it's very similar to what we did in list, okay, Python list. So you can use the same approach to slice and index an existing NumPy array. Then we saw that how to create a array from an existing array by again the concept of slicing. So yeah, that is what we have discussed in my last video. So today I'll be talking about many concepts. So first of all, I'll just quickly show you the basic methods that we have. Say if you are having an array, so you already know that in this way we can create an array. So if you have something like this array, then definitely, yeah, let me rerun it, just do quickly. So it ran. Okay, so now you can use this min, max and sum function definitely on the NumPy arrays to get the corresponding element. So min is 1, max 4 and then sum is 10. Okay, now we're going to see a concept of broadcasting. Okay, so what is broadcasting in Python in terms of NumPy? Okay, so suppose you have it's a very simple concept. So suppose you have already an array which says 1 comma 2. Okay, so let's say this A is actually an array of miles. Okay, so I'll just change it. So you have this miles array. Now since this is the miles array, so this is 1 mile, 2 mile, right? But like you want to continue this experiment or this coding with kilometer, not miles. Okay, so what you can do, you can just convert this miles to kilometer by just multiplying it with 1.6, right? So NumPy allows you to do that. Like if with vector, this is a vector, right? So with vector you can like multiply, add or do any operations with scalar. Vector and scalar can be added, multiplied together. Okay, so you can just say miles into 1.6 and you will see that it has been multiplied. This 1.6 has been multiplied with each element. So NumPy knows that if you are multiplying this scalar value with this vector, then it should multiply each element with that scalar value, right? So this way you can do any kind of operation. Similarly, if you have a like this is, if you see this miles 1, this is an array, and if you have some other array called miles 2, let's say, which is 2 and 4, so you can do miles 1, miles underscore 1 plus miles underscore 2. You can do that. So if you just run it, and you will see that it has been added. right? So it's very important to know that NumPy will only understand if the dimensions are compatible. If the array dimensions are compatible, then only you will be able to add or multiply or something. Okay, so by compatibility I mean if you have a compatible shape of miles 1 and miles 2 or not. So we have a compatible shape, right? Both are like 1D array, so we can add. And also it supports vector into scalar, that is a single value also you can add, but it's not possible to add 2 by 3 matrix with 3 by 2 matrix. Okay, so that dimension adding, so that's a different dimension, so you cannot add it and you will get a value error. Okay, so suppose you have this miles 1 as 1.2 comma 3, and let's say this miles 2 is same. Okay, so if now you are going to add this 2, you will get a value error. So let's do that. You will see the value error. Okay, that this is not possible, this broadcasting is not possible. That's the exact error. Yeah, now you can use unique. So in NumPy we have a method called unique, so you can use unique. It's a very important method, and it has lots of special abilities to perform various operations. So let's say we have an array which says np.array, and let's say we have a many more elements. So let's say 12, then 13, then 14, 15, 16, 17, then again 11, 12. So we have lots of duplicate values, let's say we have. Okay, something like that. Now if you do np.unique and just pass this array, it will return, so we have a 1, so it will return an unique array. That means all the unique values will be returned. Okay, so this is one operation that you can do with unique. Now like I told you last week, that if you do shift tab, just do shift tab here, and you will find out that there are like so many parameters. Okay, so if you see, there is a return index, return inverse, return counts. Okay, so that means, so these many parameters you have inside unique. So if you just pass this return index equals to true, basically, so just say return index equals to true, so what it will do, so we'll see that. So it will basically do, it will return the index as well, along with the values, along with the list of unique values, it will return the index as well. So it will return two elements, basically, this method. Then so we have to just say that, let's say unique values and comma index. Okay, so we can do unique indices, we can do that. So we'll just pass this, and now if you print unique value, it will print the same thing. But if you print this unique indices, you will see that all the unique indices has been passed. Okay, so if you see 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is unique, 0 is unique. Again it is sorted, so that is why it comes like this, but like these are the unique indices that you will see. So like corresponding indices, like 1 is a corresponding index having 7. Okay, something like that. Now you can also pass return counts. Okay, so this is also a very important concept. So let's say you will pass this return count equals to true. Okay, and say unique counts. If you do that, so now if you just want to print this unique counts, you will see that it counts that this element 1 exists only one time. Okay, in the whole array. 11 exists only two times in this array. If you see 11 and 11, So this is the basically count, the frequency you can say. So now which is the, so this 12 having 4 times. So if you see 12, 12, 12 and then 12. So like this you will get the counts as well. You can use the same unique method for 2D array as well, but when you are doing a unique on 2D array, it will flatten and return the unique elements. So basically what I'm saying is, so if you have this an array like, so 1 2 3 and then you have 2 3 4 and then you have 3 4 5. Okay, now if you do np dot unique and pass this array, so you'll see that only the unique values have been returned and it's a flattened array. Okay, so since this array is a 2D array but the returned array is a 1D array. Now you can use this again for a particular row or column as well. Okay, so for that you have to pass the axis, whether for row it will be 0 or for column it will be 1. So suppose you have this 2D array again with you, so I'll say 2D and it has a duplicate row, let's say 1 2 3. Okay, now if you run it and say np dot unique and you pass this array 2D and also you pass the axis equals to 0, that is you only need the unique rows. Okay, so before that I'll just show you how this array looks. Array 2D looks like you have 1 2 3 2 times, right? So now if you do this, you will see that the duplicate array has been removed. Now let's say you have a like duplicate column. So if you having a column, say array 2D equals to, so let's say np dot array and then you have 1 2 3 first row, I'll pass this as well as a 2D array and then so again you have like let's say 1 1 3 you have here you have 2 2 maybe 4 and here you have 3 3 maybe 5. Okay, so now if you print it array 2D, you will see that we have a duplicate column, right? So now if you want to remove that, you will just say np dot unique and then you will pass your array 2D and here you will pass axis equals to 1. So you will see that the duplicate column has been removed. Similarly you can pass the return count, which is like return counts, then return index as well for each array, for each like row of a matrices. Okay, and you will get the corresponding values as well. So this is we have for new unique. Now you can also do transpose of a matrices, right? So if you have a matrix called, let's say matrix equals to np dot array and you have a 2D array, let's say 2 3 2 3 4 then 11 12 13 and then you have 5 6 7. Okay, so just to show you what matrix looks like, so like this. Okay, now you can do a transpose, so you have a transpose method as well. So if you do transpose, just do T and tab, you will see that this is a transpose method and do just this and it will show you the transpose. But there is another way of displaying transpose as well. So just do dot T, it will also do the same operation. So we'll get a transposed matrix from an existing matrix. Now a very important concept of NumPy is flip, like reversing an array. Okay, so if you have an array let's say like this, which is 1 2 3 4 5 6 let's say I'll just choose the unique values. So we have this. Okay, so you can do np.flip basically. So you can just say np.flip and just pass a. It will reverse the array. And similarly you can do for any number of dimensions as well. Okay, so suppose you have a 2D array again. So let's say a underscore 2D, and you have this basically this array, let's say something like that. So you have 1 2 3, and then you have 4 5 6, and then you have 7 8 9. Okay, let's say like that. So you have a 2D array. So if you do this np.flip, let's say, and type here a underscore 2D, so it will reverse the each row just to show you the array first. So it's like that. Now if you do this, you will see that, right? So each row and each column both are flipped basically. But again you can pass the axis to only flip either the rows or the columns. Okay, so suppose again you have a, let's say, this array, and say 1 2 3 4, and then you have 4 5 6 7, and then you have 7 8 9 10. So I'll just show you how it looks. Now you can just say that reverse this array by rows. Okay, if you do that, so what it will happen is, like, this array, this row of this matrix will be the first row, right? 7 8 9 10, and then 4 5 6 7, and then 1 2 3 4. So if you just say np.flip and then pass a underscore 2D and then say x is equals to 0, so it will reverse the rows basically. So it will be there, and this is something like that. Now if you can do the same thing with columns. So let's say calls, and you will pass this is equals to 1. So again if you see this, so only the column has been, so this 1 4 7 is the last column now, and then 4 7 10 is the first column now. So basically like this you can flip. So you can also flip only one array, one row of an array of a 2D array, or only one column of a 2D array. So suppose you have again this 2D array, let's say like this. Okay, and then just you want to reverse this second, only the second row. Okay, so what you can do is you can just say np.flip a underscore 2D and pass 1. Okay, right, so you can just say this, so it will only reverse this one, and you can just assign another, let's say a underscore 2D 1. Okay, and now do this, so it will only reverse the middle array, middle row basically. Okay, so it's very helpful methods you have for this flip. And for column, if you want to do for column, so suppose you have this, and you want to do for column, so let's say column, the second column you want to flip only. So in that case you can do a underscore 2D, and then for the first I mean the second column you will say np.flip and just say a underscore 2D and do the column. Okay, so now if you again see, you will see that the second column has been only flipped. 258 has been become 2852. Rest of the columns remain same. That is quite amazing. Now we'll see how to flatten a multi-dimensional array. Okay, so let's say you have a 2D array, so I'll see that how to flatten multi-dimensional array. Okay, So let's do that. So suppose you have again an array, let's say np dot array, which is 2D array. So we have 1 2 3 4, then you have 11 12 13 14, and then you have one more row called 21 22 23 24. Okay, so now you can just say a underscore flatten equals to a dot flatten. So this is a variable name and this is a method. Okay, so if I do that, now you see that this a underscore flatten is basically the 1D array. Okay, but if you do a underscore ravel, this is also will do the similar thing. So a dot, so again there is a method called ravel, so it will also show you that it's a flattened, it's a 1D array. But there is a difference. Okay, so the difference is, so flatten will not change the parent array. So now since it is flattened, if you just say a flatten 0, the first element change it to 98. It will not change. It will not change the parent array. There is nothing 98 here it is showing, right? But if you change the raveled array and do this a equals to maybe 91, now if you try to see that the parent array has been changed. Okay, so that is the difference between flatten and ravel, but both are doing the pretty much the same thing. Okay, now we will talk about some random number generation. In NumPy, basically we have a method called random, which is under this NumPy. So you will see that np.random. If you do that, you will see, and from this random module you can generate random numbers. Okay, for machine learning and deep learning, this will be a very important thing to remember, and it will come up very often in your future data science or machine learning endeavors. Okay, so the thing is, like, this nb.random uses different mechanisms basically to generate random numbers. Okay, one of the very important method of random module is default RNG. So RNG is basically a generator. Okay, it generates random number. So random number generator, that is why it's RNG. So if I do that random number generator, so if I do that, okay, so I created the object of this default range. Okay, so now if you do this and say standard normal, okay, and let's say 5, then it will draw a sample of 5 elements from a normal distribution, from a standard normal distribution curve. Okay, so I'll come to this entire statistics part of this data science and machine learning later, but just for the time being, just keep this in mind that this standard normal method just draws a sample. Okay, sample from a standard normal distribution basically. Okay, so what is standard normal? Standard normal is basically our normal distribution where we have a mean of 0 and standard deviation is 1. So what is mean, median, mode, standard deviation, variance, bias, everything I'll cover in my statistics classes, but just for the time being, to understand what a random number generator does, so this is a very good example. Okay, if you just see the doc string, so you will see that draw samples from a standard normal distribution where mean is 0 and standard deviation is 1. Okay, so I'll quickly plot this data to let you visualize what it actually means. Okay, so for that I'll just import one library, Cborn, but this library I'll cover in detail in my later part of machine learning and data science classes. Okay, but just to know, just to see what I'm actually talking about, I need this to import. Okay, and I'll quickly show you what it means. And about this Seaborn, there is one other library called matplotlib, okay, which is basically a library of data visualization. So I'll just show you the hist plot. Hist plot is basically a plot where, like, you will, if you do this shift tab, you will see that this is a plot, univariate or bivariate histograms. So basically univariate means like if you have one variable, bivariate is like two variable. Okay, so this is a histogram, so it will basically plot the histogram to show the distribution of data sets. Okay, so here I told you that standard normal draws a sample from standard normal distribution, but how it looks like, right, that I'll show you here. So if you see, I'll just say this and I'll plot, just say this, and let's say I'll put 10. Okay, so you will see that it's basically a kind of a standard normal distribution. Okay, so like, but if you put some mode variable like say x100, so you will see that this is the curve basically. So like, see this 0, so it's in the middle, right? So this is the mean, and mean is 0, so that means it's a standard normal distribution where mean is 0 and standard deviation is 1. If you put 1000, you will understand it more easily. See, still this is 0 mean and standard deviation is 1. So this is basically a standard normal distribution. You have also, so there are like other than distribution as well, where you will see the exponential distribution. So I'll show you that as well. So if you just say just do this standard exponential, so okay, so let's say 10, so it will again draw a sample from a exponential distribution. So if you just do shift tab, you will find out that a standard exponential distribution. Okay, so now again, if I plot this histogram of this distribution, you will understand what it actually means. Okay, so I'll show you just to see that. Now let's say 100, so it is, so see, this is a skewed, it is skewed data. Okay, so exponential data which is skewed, it's not a distributed normally. Okay, the data is not distributed normally. So this is basically it. Okay, for the random number generation. And for, so this is very important, but again I'll tell you everything about this Seaborn, the about plot and everything in my future classes. But for the time being, just to keep this in mind, just to understand what standard normal means, I just showed you this. You can also use np.random.normal. So this is also a method to, like, again draw some sample of normal distribution. But here you can, here you see that this is log, this is scale, right? So this LOC is basically mean okay, it means mean, or, and this scale means standard deviation. Okay, so if by default it is, the mean is 0 and the standard deviation is 1, so by default it will draw a standard normal distribution data. But if you can also pass your customized mean and customized standard deviation to get a normal distribution data, not a standard normal. Standard normal, just keep this in mind, standard normal means mean equals to 0, standard deviation is 1, which is the default value of this. But you can have your own mean and standard deviation as well. Okay, so yeah, this is again, it will draw. So if you just pass like say 10, so it will, you have to pass the shape basically here. So let's say 4 by 4. Okay, so it will the, yeah, so this is basically size. Okay, you have to just say size equals to 4 by 4. Okay, so it will return a 4 by 4 standard normal distribution data. Okay, perfect. So, and So again you have like np.random.rand, you have it's a random.rand as well. So here again you can just pass the size. So again if you do shift tab you will see that random values in a given shape. Okay, so this is the shape that you have to pass in the parameter. So let's say you pass 5,3, it will not follow any distribution, it will just randomly pass you the data. And which one more thing to notice is that it will always generate a data inside 0 and 1. Okay, between 0 to 1 the data will be generated. So if you want more than that, so you can just do into 10 and you will get something like that. Okay, so it's very interesting concept. So and so you can also do help. So you can just say help np dot random dot rand. Okay, then you will get the entire details about this method. Okay, and so since this numpy is a huge library, you just use your np dot random or np dot any other module. Okay, and try to explore numpy in a better way from the numpy original documentation. Okay, so the documentation of numpy is very specific. Numpy has its own website as well. Okay, so you can just do google and you'll find out. So you'll see that there is a random. Okay, so there are like lots of methods and everything is there in numpy. Okay, so just use this documentation to gain more knowledge of numpy. But what I told you, it's basically almost 90% will be covered. You don't need more than any other methods that we have already used. I showed you, but sometimes you might need it. You might feel like for any kind of complexity you want to use some different methods as well. So definitely you can do that using using google. Okay, so I'll definitely advise that you use numpy documentation very minutely. And because of this advancement, because of this research, and the like whole lot of research is going on in data science and machine learning, so every day it's getting upgraded, right? So to keep very relevant to numpy and all, you have to regularly check the numpy documentations, or for that matter any library documentation, because it might happen that some parameters got deprecated. Okay, some parameter got scrapped. Okay, some new parameters added, some new methods have been added. So it is possible because it's still in a research and development phase, so it is possible. But and that is why you have to follow this python documentation, this numpy documentation. And one last concept of numpy is like you can also read the file and also save some data into a file as well using numpy. So there is one method called np dot, I think, np dot save. Yeah, so here you will pass your file name, let's say my numpy dot npy, and you will just say so .npi is the extension of numpy. Okay, so you can remove the extension as well, and you will just pass the array. So let's say this is my array. Okay, a. So I'll just pass this a. Okay, so this will be saved in my the folder that I have opened this Jupyter notebook on. Okay, on that folder this file will get saved. So now if you want to load this file, you will just say np dot load. Okay, and just do my numpy something like that, my numpy dot npy. And if you just want to print this p, you will see that yeah, it has been recovered, it has been loaded basically. So that is it for numpy. I hope like I have covered like almost everything about numpy, but still there are like whole lot of things you can also explore in numpy. Please do that and let me know in the comments that if you don't understand any of the stuff, I'll try to explore that. I'll try to cover that in my next videos as well. And in my upcoming video I'll talk about pandas, which is also a very extremely important if not the most important Python or data science or AI machine learning library. Okay, so everything about machine learning and data science based on this Pandas library, which I'm going to cover in my next video. Till then, guys, thank you and goodbye and happy learning.
If you like my content, please like, share and subscribe.